Micah. All right. Well, hello everyone, and welcome. So yeah, we have our exam on Wednesday. So I wanted to do a small little live stream to, kind of discuss some of the topics that we'll be covering on the exam, and yeah, just kind of go through and answer any questions anyone might have. So before we get started, I know I sent an email this morning, but I know that was only like an hour or two ago, so I kind of wanted to reemphasize what I was talking about in that email. Basically, the way it's going to work is that the exam is going to be Wednesday, and just like exam one, you'll be able to take it either in person in this classroom or virtually, wherever you would like. And for the virtual exam, it'll be open all day, anytime from you started the day to the end of the day, as long as you finish the exam before midnight, that will be fine. And yeah, so that's the standard kind of thing on that end of the spectrum. And then the other end, the other part of exam 2 I want to mention is diagrams. So not nearly as intensive as, say, the abstract syntax trees and parse trees, but there will be maybe some diagram stuff on exam 2 as well. And so what I've decided to do is that for those who are going to be taking the exam in here in person, you can do your diagrams on paper. Bring in a blank sheet of paper on top of the normal scratch paper you're going to be using, right? And you can do your diagrams on there. Just label the question, write your name and on the paper, and then just in respondus on the exam, just write, turned in paper in person. And I'll keep a stack of papers. And if you're going to be taking the exam virtually, you'll get an extra couple of minutes to finagle with the software. So that's kind of how I'm balancing it. If you're taking it virtually, you get a little extra time, but that really is just to use the extra software. And if you're taking it in person, you don't have to worry about that because you can just write it on paper and not have to deal with this dumb piece of web software. I think that might be a best of both worlds scenario. I mean, that's obviously kind of what I'm trying to go for here. And so that's logistically how it's going to work on Wednesday. So come in here in person, do all your diagrams on paper, do your exam virtually, and you will do your diagrams on that web service, and you'll get a little extra time to compensate for it. Can't give any extra time in here because I know there are people who are in here right after us, so we are on a time constraint to give the exam in person. So yeah, that is kind of what I wanted to say about the exam. Yeah, that's really all I want to say about the exam. Yeah, so basically one of the other things I wanted to talk about today was I kind of wanted to go through the study guide and see if there are any points or topics that people wanted us to cover, to discuss, to go over, and really just to have an opportunity for me to answer y'all's questions about everything and, yeah, finalize and answer these questions before our second exam Wednesday. So yeah, that's really it. I don't really think there's anything else I have. Everything else is either returned or being graded in the moment. And yeah, just kind of trying to, grind through it. I hope you guys all enjoyed your reading day long weekend, as it were. So yeah, I don't think there's anything in here that I particularly explicitly want to cover. Because this is just the study guide. I can also answer questions. I know we had assignment 5 and just things that are coming up in the Common List project. I didn't really know where people wanted to mainly focus on, if Unit 3 or Unit 4 was more of an interest today. For those of you who are watching on the live stream, if you have any questions at any point, just drop them in the little YouTube chat over there, and I'll be happy to answer them. Does anyone want to get started? Yeah. Yeah. Yes. So the question here is, what are the types of memory management that we've discussed? And so I'm struggling to find it on the sheet, but basically the 3 types of memory management are manual memory management, right? Manually doing it yourself, garbage collection, and automatic reference counting. You'll see explicit slides for the last 2, right? We talk about garbage collection and automatic reference counting a little bit more explicitly because those are mechanisms that we are utilizing and designing for the purpose of memory management. We don't really have a slide on manually managing your memory because that's kind of seen as the default, but that is the third type that we are expecting you to know here, right? Manually managing your memory, using a garbage collector, using an automatic reference counting system of some kind. So the question that, is assignment 5 going to be back before the exam? We'll see. I'm trying to get them done. I'm not sure I'll be able to. So what I'll say is, optimistically, I would like it to be, but if it's not ready, then I apologize. Trying to just kind of keep everything returned and graded, and unfortunately I had a bunch of midterm exams to grade for my 200 level, and that kind of kicked me a little behind. So apologies for that. I would like to try and get them done, but we will see if they actually do. Which is again why I'm having this review session. If there's anything on assignment 5 that you were unsure about or had questions about that you wanted me to cover in here, I would love to do that and kind of give some more definitive answers to some of those maybe question marks. Yeah.
Assignment 5 had a big question. Dynamic versus static. So
Yes.
I understand that. I think I understand the difference between them. However, I have a hard time understanding the question and how it properly works.
Okay, yeah. Let's pull up assignment 5 then, and let's take a look at that static scoping, dynamic scoping question. And let's see if my tablet will play nice, because that might actually help us out a lot today. And then yes, Microsoft Word. Okay. And let's see if the tablet wants to play nice. Oh. Seems that I don't have the pencil. Is this going to be sufficient? No. Huh. Seems I've lost the pen. Oh well. Okay, I guess I'll just have to make do without that then. So basically, right, what we are asking our question about here is basically just question number 1, right? So we're asking here, right, determine the symbol table and output for the following code. And we are asked to use static and dynamic scoping to both determine the symbol table and to determine the output. So, sorry, I'm a little bummed about this lack of a pencil here. You know, it used to be you bought a piece of hardware and then it just worked. Not, hey, we updated your software without telling you and then we bricked your system. Which is my favorite way of modern software design has advanced. That's definitely a huge improvement. I don't have a digital stylus anymore. Okay.
So I guess one of the first questions.
Yeah.
My understanding of static scoping.
I'm just improvising how I want to do this because like I normally use a pencil here. I think I can just, instead of using a pencil, I'll just manually draw it. So apologies, this is going to look terrible. Tablet is just one of the more finicky things in the universe these days. So basically, though, here is roughly kind of how I'll do it. Yeah, there we go. All right, yeah, let's do this, and I'm going to hand draw it again on paper with my finger, so it's going to look kind of bad, but hopefully this conveys the point. So then I should just have to go here, here, here? Okay. Cool. All right. So we're going to try and utilize that. And okay. So basically, I'm going to say like we start with the symbol table, right? Because if we understand the symbol table and basically how the values are in scope or out of scope at different points, I think that the actual outputs aren't nearly as challenging. I think if you understand the symbol table side of things, you should be good with the output side of things. So basically, if we want to use static scoping to determine our symbol table, right, then what we are going to want to do is we are going to want to analyze this source code from top to bottom. Again, that's the major distinction between statically scoped languages and dynamically scoped languages, is that statically scoped languages follow a standard top to bottom analysis that can be done pre-execution time, right? And dynamically scoped languages require a runtime execution path to follow. So that's your distinction here. So if we're going to do a statically scoped language, and we want the symbol table, then we will develop our symbol table basically coming top down, right? That is for a statically scoped language, the direction in which we're going to generate this symbol table. So the first thing I want to do here when I generate this symbol table is that I'm going to start at the beginning, right? The first thing we have here is A. So I'm going to come to the symbol table, and I'm going to make an A, and I'm going to draw that onto our symbol table. And we see that A has an int value, and that it is a global value. So over here, I might do something like int global. It's not global, but I don't care. And that would go on our symbol table, right? So we have A is int global, right? Because A is a global variable defined on the first line of this output, right? The second character here is going to be B, which is going to, again, be this time a char. God, is there a way I can, like, just suck less at typing? Let's see. Oh, you know what? I can do that. That's way nicer. Okay. All right, we can do that instead of me trying to scribble very ugly little characters here. And we can put that onto the symbol table, right? So basically, after the first two global statements, that is the state of our static symbol table, right? A is a global integer and B is a global char. And then as we come down, we hit line 3. Now, on line 3, we have actually two different declarations here, right? The first one is that we have function q, right? Now, function q comes on here, and actually it should be lowercase q. Function q comes on here, and we would say that this is an int function, right? Just the idea that q is a function and that it is a return value of type integer. We don't really need to specify global because in this, we're going to just assume we don't have anonymous functions, and we'll just assume that all named functions are globally accessible, right? There's no local function definitions in pretty much any programming language. They're either anonymous functions or they're globally bound to a name. So we're just not even going to specify that in our symbol table. We'll just assume all functions are global. If you specified in global function, there would be no harm there, right? We don't have an explicit list of attributes, right? We don't have a definitive, this is just an abstraction. Any actual language is going to have to implement its own set of rules, and we're just kind of doing it on a top level. So, right, we have something like that. We come down here to q in function, right? And so that is the state of our symbol table. And we also see that we have this local variable char p. And so because this is a parameter, this is also something that should go on our symbol table, right? And so we come over to B here, and we'll put this on the top of the symbol table, and we'll say char B local to Q, okay? So now we have, oh, this doesn't really need to be chart B, does it? Well, I can't really do anything about that. Oh my God. Love to see. Come on now. Can I not? Did it just? All right. Okay, it's deciding to work again. Sort of. What the fuck? Doesn't like me drawing over the text. I don't know why. All right, sorry this is like an actual disaster. I am very happy with my computer right now. But basically, what I'm trying to write on the screen here is that we are supposed to have char local to q, right? The idea that when we hit the parameter on line 3, that is a local declaration of a variable, and so it goes on top of the symbol table. I can't erase. I can't. Just won't let me. All right, I guess that's just kind of how we're doing it now. Oh, okay. Never mind. All right, that makes sense. Okay, so we have char, which is just local to q, and then we keep coming down our symbol table, and we see here we have int a, right? So this is a local declaration of a, so I'd come on top of the symbol table here, and I would say something like int local to q. Okay, so we have int local to q now on top of the symbol table. Now, the important thing to note here about this is that these local int declarations shadow over the global declarations, okay? And so that, and this is going to be the state of the symbol table at line 7, right? These are all the declarations, right? We have the A as a global declaration, B as a global declaration, and then we have A as a local declaration on this line, and B as a local declaration in the parameter. So we can see that we have local versions of A and B inside of int q. And if we are to access a value of A and B, we would be accessing the local declarations rather than the global ones. Now, this is the answer to part A, right? You static scoping determine the symbol table at line 7. And this is also something we can use for part C, right? Using static scoping to determine the output. Because if we know at this point in the program's execution that the values that we are going to access in variable A and B are going to be the local declaration, that means when we actually execute the program starting at main, right, we'll know to use the local declaration of B and A for the output values. And that's the beauty of static scoping, right? Okay. So a couple of points here that I want to make kind of before I continue and answer some questions here in the chat. And so there's a question of, is there a particular order for how the symbol table is organized? The answer is no. The way the symbol table really ought to work is just kind of this notion of this, basically each name is on a stack. Whether or not you orient that stack left to right or right to left is not, doesn't really matter. As long as it's clear that, as long as your orientation is consistent, and then I'm okay with that. If you want to mark a little arrow indicating, because I know on Sometimes I have written them one way and written them another. Really, as long as we're kind of conveying the fact that each letter is a stack and that the top of the stack is the value that is currently accessible, that's really all I'm trying to get across. The way I'm writing it on this like review guide is really my preferential way, but I know some of the slides in the lectures kind of go the other way, and so I'll accept either one. If you're really kind of concerned, just use an arrow to kind of indicate where the top of your stacks are. But other than that, it's not something I've had any issues with. So yeah. And the second thing I want to address here is that if the function itself has an argument, is passing an argument, then that only really matters when you're trying to understand what the value of a variable is going to be. The parameter, though, is important just for the symbol table, right? Because we'll notice here in Q that acknowledging that char b is a parameter means that this is a variable local to function Q. So we do need to acknowledge and account for all of the parameters that we have when we are doing a static or dynamic scoping, right?
The slides during this topic
Yeah.
do also specify that the value when defined is considered an attribute as well and was added to the symbol table. Is that expected?
So here's the thing about the value part of this. So I'll have two, I see there's questions in the chat, so I'll answer two questions about this. So when it comes to the symbol table, whether or not there are values is determined based upon what type of scoping you're using. If you are in a statically scoped language, there should not be any values on the symbol table because you do not have the value of your variables until runtime, and in a statically scoped language, the symbol table is generated at compile time. So you actually should not have any data values on a statically scoped symbol table. Whereas a dynamically scoped symbol table, because that is updated and maintained at runtime, the values may or may not be available, right? And so whether or not the values in a dynamically scoped symbol table are on the table is optional. You can have them there, but you do not need to. Whereas if you have a statically scoped symbol table, you cannot have the values because the values are not available at compile time when that symbol table is generated. So a good just rule of thumb is that you do not need them, right? There's obviously a little bit more nuance, but if you're trying to prepare for an exam, your symbol tables don't need the values, and that will keep you in the clear, okay? And so to that credit, right, when we're trying to do something like dynamic or static or dynamic scoping, but try and do parts C and D where we actually figure out the output of these questions, then what I would say is that the values are important, but the symbol table isn't particularly necessary for the literal values. It's just kind of what is in scope, right? So basically, if we're doing a print out here of variable A, the kind of question is, do we print out the global variable of A, or do we print out the local variable of A? And in this case, we would print out the local variable. You're going to still have to kind of do a bit of an analysis to figure out what the value of the local variable is at this point. But that analysis really isn't that bad, right? At this point on line 7, if we know that the local variable A is the variable that's being utilized, then we know its value is just 89, right? B is a little bit more complicated, right, because it's the parameter. So you need to actually follow the execution path a little bit for that. But even though we have to follow the execution path to get the value of the parameter, whether or not the parameter is in scope or not, whether or not the parameter is the thing being accessed, we can determine at compile time, right, in our symbol table. And the other thing I wanted to do is do a quick kind of demo here about just finishing this out. So I'm going to do my best to do that. So as we get to the end of A here, right? Oh my God. So as we get to the end of A here, right, we come down, we hit return A, and then function Q is over. So when function Q is over, we actually take these values and we get them off of the the symbol table, right? They're no longer on the symbol table after int q is finished, right? So when we are at, say, this point in the program's execution, this is what our symbol table looks like, right? We have A, B, and Q, but A and B are globals, as the locals are now out of scope, and we have left function Q. Yeah?
The symbol table does not stay around throughout the program's life cycle?
So it does. Well, no, it doesn't.
It does not.
No, so basically the symbol table in a statically scoped language is gone after compile time. It does not exist in runtime. So as we come down here, we'll note that we have void p, right? And so as we reach void p, right, we come here. We set down function p, and function p we'll just say is again an int function, right? So we have p as an int function, and then we can just quickly go through p, right? We notice here that we have b, right? So we just have a local variable b, so I'll come in here and I'll see double, why? Double local to p, right? So we have double local to p, and then that's really it, right? And then we come in, right? There's no local declaration of A, and so at this point in the symbol table, right, we can just kind of look down here, and if we need to do a printout of value A, we know we're using the global value of A. Whereas if we need to do a printout of B, we know we're using the local value of B. And, you know, again, not to harp the point to death, but then we come down, we would add the same thing for main. So we would do something like main is an int function, and then main has a local, right? Oh, God. And then main has something like, it is a char local to main, right? So we have a char local to main from right here, and then that's really it. So if we access the value of b at this point in the main method, we would be using the global value of b, right? That is how static scoping works. So hopefully, I apologize for the janky-ass demo, but hopefully that makes a little bit of sense. And then really quickly, for something like, dynamic scoping, right? How would we do dynamic scoping? So for dynamic scoping, basically the way we do dynamic scoping is rather than doing this kind of top-down approach that we do in a dynamically scoped language, instead what we do is we utilize a runtime-based approach, right? So we start at the program's beginning and we execute statements through using that to determine the symbol table, right? So in a dynamically scoped language, the actual scoping happens at runtime, which is different from a statically scoped language. So we'll see here, right, we do int main, and then first thing we'll notice is that we have char a local to main. And I'll also say that a dynamically scoped symbol table has to do a global pass first, right? It does need to start, so the symbol table has to be generated following the actual runtime execution path, but the only way for the runtime execution path to make any sense is to have all of the functions and global variables already placed on your symbol table. So for a dynamically scoped language, you can imagine it has a global pass, right, where all of the global values, both functions and variables, are placed on the symbol table, and then we start executing code at int main, and then as we go through int main, we start placing things onto the symbol table. Yes? Yes. Yeah, that's exactly correct, right? Like at the start of int main, this would be the state of the symbol table with A, B, Q, P, and main already on there. Yeah, that's absolutely right for dynamic scoping. And then what happens is we'll see there is char A. So this is going to be char local to main, right? So now A is a char which is local to main. Now, the difference between static and dynamic scoping is that static scoping is this kind of top-down. And so when we leave a function in a statically scoped context, all of the local variables in that function go out of scope. But in a dynamically scoped languages, things do not go off the symbol table until the function has completed. So if we leave a function because of a call somewhere else, but the original function has not yet finished, then all of that non-finished function's local values are still on the symbol table. That's really the make or break difference between static and dynamic scoping. And we can see an example of this when we come down to this P function call. When we do a function call to P, we come up here and we declare double D local to P, but we don't actually get rid of this char local to main. Okay? And so at, say, this point in the program's execution, right, we come down, we do char A equals L, we do print F, we then call function P, we come up to function P. The first thing we do in function P is we create a double local to P, right? So we have a double local to P right here. Then we print out the value of A and the value of B. This is why dynamic scoping is deemed weird and bad in most modern circles, because the value of B that we're going to be using is the local value declared in function P, as kind of one would expect. But the value of A that we're utilizing is the one declared in the main, because main hasn't finished executing yet, so its local variables are still on the symbol table. So when we go to execute this print statement in function P, the value of A is the value of the local variable A in int main. Yes?
Is that C specific?
That's dynamically scoped. So any language that's dynamically scoped does this. C is not traditionally dynamically scoped, so that's not how traditional C programs work. We're just using C as an intermediary language because no real language is dynamically scoped anymore because it's a little absurd.
So languages like Python that are typically more as dynamically scoped or?
So languages like Python are traditionally statically scoped, even if they are somewhat dynamic in nature. They follow traditionally static scope rules. They just do them at runtime.
Okay.
Yeah. Language, like a lot of times modern languages take these two very discrete concepts that we are defining and then play mix and match blender with them, which makes them a little bit hard to suss out exactly what's going on, right? A language like Python is obviously dynamic in the sense that it's all happening at runtime, but because dynamic scope rules make such little sense, it's actually doing a bunch of static scope rules at runtime. And it's this kind of ugly rat's nest of weeds and, you know, that it's not super fun to get into. So for this, like, we try and distill these two concepts separately, and then we'll see how they get kind of messy in the real world. But for these kind of questions, right, we're just trying to keep these as distilled and as separate as possible. Yeah?
We call P in main, we're not passing in any arguments. So then why would A not need global variable?
Because the main function hasn't finished. So the local declaration for A in main is just still on the symbol table. It won't come off the symbol table until int main actually finishes. And because we made a call to P, int main hasn't finished, right? It's still waiting to be done. It's waiting for the value of P to be returned.
And pure dynamic scoping is kind of naive.
Yes.
It simply pulls the last value off of the
Yes.
table stack for that variable.
Yeah, that's a perfect way to frame it. Like, dynamic scoping is naive. No, I like that a lot. And so that's going to be the weirdness of dynamic scoping, right? That at this point in the program's execution in function P, the value of A is the local declaration in main, and the value of B is the local declaration in P. And this continues down on this function call, right? Because when we call function q, right, q comes in here, but p is still not finished when we call function q. So the local declarations inside of p aren't gone. And we also have a value of a as the argument here. And so when we're printing out a or passing a as an argument, you're going to need to use the value defined in main, not the globally defined value, if you want your outputs to be correct. We call function q, we come up here, and we actually, again, it's important to note what's going on here, because we have two declarations, a local declaration for b and for a, because the parameter counts as a local declaration. So I would come over here and I would say something like for a, it would be int local to q, and then for b, it would be char local to q. And that would be the state of the symbol table at the printf in function q. Yes?
Another question. So dynamic scoping starts top of the program and has to do a global password.
Yes.
When it does that on line 5, when you have int q char b, is that done in two separate passes?
Yeah, that would be, so for something like that, the actual function itself would go on the symbol table, but the actual local declaration of the parameter would not happen until the function itself is called.
So it's two statements on the same line that are
Yes.
separate steps.
Yeah, that's exactly right. It's two statements on the same line that are done in two separate parts. Yeah, that's 100% right. And then basically, just to kind of finish this out, right, we print out the value of a and b, which are both the local declarations in q. And then once function q is over, the values local to q come off the table, right? And then once these come off the table, we come back down to p, where it modifies the value of a. But then after that modification, function p is done. And so that means the variable local to p comes off the symbol table. And then once we come back down to main, right, once main is over, right, this would come off. But once main is over, the program's over, so it's not like it really matters. But that is going to be your dynamic scoping path. And again, you can utilize the dynamic and static symbol tables not to get the values exactly, but to understand what variables will be in scope at what points and use that to get the values. Yes? So if I asked you a question on the exam, I would make it so no lookup table was necessary. I like this for the project to kind of force you to think about interpreting data in different ways, but I wouldn't be that mean on an exam. On the exam, I'd keep all the data types consistent and just make sure you understand which variable is being accessed, whether it's a local or a global or what have you. Right? You will need to keep an eye out for tricky garbage like this line down here, a equals q of a, because that will update the value of the variable. So you'll need to keep your eye on stuff like that to make sure you know what's getting updated where, what values you're pulling from. But I wouldn't have you do anything like a lookup table on the exam. Okay? So apologies that took forever because I was trying to jury-rig a way to do it that was legible. So basically, I'm going to end my drawing right now. And so I want to really quickly go over a few more questions. Oh, are we just going to do this? I thought we were done. Clear screen. Yeah, it would only update on return. That's correct.
What was the question in return?
It would only update on return. Why? Yeah. Just, I don't, oh God. All right, so question 6. Okay, cool. I don't need a diagram for the rest of these, which is nice. So very quickly here, question 6, right? Default arguments in function definitions such as void print int x, int x, comma, int base equal 10 present a problem for overload resolution. Describe the problem. Okay, so kind of, the question here is, why does this make overload resolution a problem? So the first thing here, obviously, is understanding overload resolution, right? Knowing what it is asking you to discuss. Overloading in this context is just the notion that you can have multiple functions with the same name because their parameter list will let you tell them apart, right? That's overload resolution, right? Two functions, same name, different parameters. And the question here is, why do default arguments throw this out of whack? And the answer is, we can solve this by doing a little thought experiment, right? If we do not have default arguments, right, we might have, say, something like a function called print, which takes in a single int value, and then another function print, which takes in two int values. We can always tell which of the function prints we're calling based on the arguments provided to the function call. If there's one int argument, well, then we're calling the function that takes one int parameter. If there's two int arguments, then we're calling the function that takes two int parameters. Pretty standard way to do overload resolution. But if we have default arguments, that means you do not need to supply an argument in order for a parameter to have a value. So if we, say, have that same situation, right, where we have one parameter named, or one function named print, which takes in a single parameter of type int, and another function called print, which takes in two parameters. But that second function print, its second int parameter, has a default value. So no argument actually needs to be supplied for the function call to be valid, because if no argument supplied for the second parameter, the default value will be used. Here's where the problem comes in. You make a call to print and you supply one int value as an argument. Which function does the compiler or environment use? Does it use the function call that takes in a single int parameter, or does it use the function call which takes in two parameters and just uses the default value for the second one? We have created ourselves an ambiguous situation here, where because we have default arguments, we can now not overload our functions, because we can get into ambiguous situations where we're not sure if we want to call one of the functions and use its parameters default values, or we want to call a function that just doesn't have the default values or the parameters there at all. That is the reason why the two concepts are incompatible. Traditionally, languages either A, have function overloading, or B, have default values. In Python in particular, what you see very commonly are single functions that have like 24 optional parameters, and the function can behave wildly differently based on what parameters you give it, as opposed to a more traditional Java solution, which would be having like 6 or 8 smaller functions, all with different parameter lists. So that's the difference between the two of them. And so the follow-up question here, are default arguments reasonable in the presence of overloading? Well, the answer is pretty much no. If you argued something that makes logical sense and doesn't come to the no conclusion, I mean, sure, you might get some points, but the correct answer is no, right? Yeah, sometimes in computer science, people can take a no and do a lot of weird programming to make it a yes, but like we shouldn't make a habit out of that if we can avoid it. And that's, yeah, kind of where I'm coming from on that. So yeah, so yeah. So 12, okay. So what are the advantages and disadvantages for Booleans to be convertible into integers? So that's number 12. And honestly, this is kind of an opinionated question, but I would say that the advantage is flexibility, the disadvantage is flexibility, right? So for a language like C, there is a nicety that Booleans can be integer values because it allows you to return multiple things in one go, right? In Common Lisp, oftentimes we return the last calculated value in a function, and that last calculated value is just truthy. So we can return the output 120, and that 120 also represents true. Whereas in a language like Java, we would have to return either a Boolean true or a numeric value. We couldn't kind of return both at once. So there's some flexibility that is gained from having Booleans be numeric. The disadvantage is now you don't have two discrete types, you just kind of have this blend, which can be confusing and can allow for things that maybe you don't want to have happen, right? In Java, you can't do an arithmetic operation on a Boolean value, because that makes no damn sense. And because Booleans are their own thing, Java can actually prevent this. But if all a Boolean is a wrapper for an integer value, well, you can absolutely do mathematics on it. And you can do Boolean divided by a number. And that kind of mind-bending stuff is valid in your language, even though logically it doesn't make a damn bit of sense. So that would be your disadvantage. Again, you can stake other positions and kind of argue them, and as long as your argumentation is sound, I'll accept the question. But that is, I would say, kind of my main point, right? The increase in flexibility is an advantage, but the increase in complexity and, frankly, weirdness that can come with that is its disadvantage, right? That would be kind of my hot take on the matter. It very much could be, yeah. I don't know enough about hardware programming right off the top of my head to definitively say that, but that seems like a very reasonable argumentative point to make, you know what I mean? Another point that you can make is that by treating Booleans as integers and having less explicit types, you have a more simplistic compile and runtime environment, right? Instead of having this entire new discrete type that you need to keep track of and store, it's just an integer, use that. So again, there's like a lot of potential answers to this question, and really, for me, it's more just making people think about it and then argue their point, as opposed to saying this is the only right answer and everyone needs to know this. Okay.
Another interesting point there is by keeping them as integer types, you usually take up 16 times as much space in those systems as you actually need to hold the Boolean value. You could hold it as integer types, but a lot of times
Right, the useful integer, yeah. Yeah, okay. So we've got like 2 minutes left, so apologies that was most of the time on the symbol table, but I hope that was at least helpful and informative. Does anyone else have any last minute questions just about kind of anything, homework, exams, stuff on the, yeah. Oh, that's not. Let me, do I still, oh, this is the study guide. So the only other thing I'd say in like these waning minutes of here, yes, so that is true. So for the exam on Wednesday, you can, as long as you're taking it virtually, you can take it any time. That's completely, totally okay with me. The only thing, if you're taking it in person, you have to be here at noon. But if you're not taking it in person, you're welcome to take it any point during the day on Wednesday. And there won't be a key release for assignment 5. Hopefully I have the grades back to you before the exam. But if you have any questions about assignment 5, feel free to just reach out. While you're going through the study guide, I mean, like, if you weren't sure about something for assignment 5, it really should probably pop up on the study guide, because you'll be kind of unsure on how to answer some of these bullet points or how to fill them out. Again, the biggest piece of advice I can give y'all is that study by like just fill this out like a Google Doc. Download this file, indent, open. If you can put the information in for every bullet point in this document, you'll be able to kill the exam. That's how it's designed. If you know what all these bullet points are, you know all the topics they're referring to, you will come in and you will just ruin this thing. And that's the goal. Yeah, the only other thing I'll say really quick, because I don't have time, is just pay close attention to the common lisp stuff. It's worth evaluating the theory. And as I mentioned last Wednesday, the first 4 homework problems on assignment 6 are probably one of your better study guides for this part of the exam. I know I'm double stacking things, but genuinely doing the first 4 assignments, understanding a practical implementation of the theory is probably one of the best ways to get a lot of this stuff down, right? How to define a function in Common Lisp, right? Both design patterns for if and if-else if. Stuff about S-expression evaluation. All of that is going to really come into play when you define this stuff yourself, and it'll be really helpful. Yeah? It would be, so any common list programming that you would have to do would be relatively short. So there is 3 levels of complexity. The stupid hard stuff that we sometimes see on the lecture slides, a medium and an easy. I would say easier stuff you might have to build yourself. Some medium level complexity might be ready for your analysis, but you wouldn't have to define that yourself. And I wouldn't keep anything that's obnoxiously challenging on there for the sake of it. That would just not be on the exam. Yes?
We haven't completed assignment 6, right? So we haven't done any programming in list
Yes.
to this point. Will there be programming in list on the exam?
Yes. Expect that there will be. Again, it won't be super substantial. I will not be asking you to build, but something basic like build me a list of con cells, right? Define me a basic function that can do a recursive iteration. That's about to the extent that I'd get, right? Like a recursive function to sum a list is probably the cap of our complexity here, right? If you've never programmed anything in CList before, that is going to be a substantial challenge. But if you've just given a little bit of the program exercises or started on the assignments, right, it's nothing too insane. That's the design for the exam on Wednesday, okay? That's how I'm trying to lay it out. Yeah, and then the last question from the Twitch chat is it okay if we send you any individual questions from assignment/study guide for extra guidance? Yes, please, absolutely. Please DM me. I'm on Discord. Shoot me emails. If you have any questions whatsoever about anything, just reach out. Let me know. I'm more than happy to give you all answers. That is literally what they pay me to do, and I'm happy to actually do my fucking job. So I think with that, I'm very over time. I want to say thank you all so much for appreciate you sticking with me as I once again have to improvise my technical side of things. And I will see you all on Wednesday for our exam, and best of luck studying for this. So yeah, with that, thank you all so much. I will see you Wednesday. And yeah, just let me know if you have any questions.